So the question we are going to be looking at today is how do we change it from standard form to vertex form? Standard form is better for solving. Vertex form is better for graphing. So the different forms are for, we change forms depending on what we are trying to emphasize. So, to find the vertex, you are going to memorize this little formula, minus b over 2a. And you're going to put little clouds and stars and check marks by it, and you are going to memorize this. Now, we've been doing the A, B's, and C's for a long time when we were factoring and solving. So, in this, what is the A? And the B? And the C? So, in this formula, it's the same A and B that we have been using from standard form, so it's minus 1 over 2a. A is a fraction, but this isn't going to be too hard because what's half of 2? And so this is negative 1 divided by 1, so this is negative 1. But that's not a vertex. A vertex is a point, and that's just one number. Well, it's the first half of the vertex. And now I need to find the other half of the vertex. So I will substitute to find y, the other half of the vertex. So you use this formula first, and then you substitute to find y. I take my original equation that I have up there, x squared plus x minus 12, and in place of x, I substitute negative 1 squared plus a negative 1 minus a 12. What is negative 1 squared? That would be positive 1 times a half. And that would be a negative 1 plus a negative 12. Now to solve this, I'm going to have to subtract. To subtract, I have to have a common denominator to subtract fractions. But it's not going to be too hard because it's just a denominator. What is the denominator, by the way? So I'm going to need a common denominator of 2. 2 times 13 is 26. 26 divided by 2 is equal to the 13, but I write it 26 over 2 so that I can have a common denominator. And so when I subtract, it's not pretty, but that's what it is. The vertex is negative 1, negative 25 over 2. So, that's the vertex. If I have the vertex, then I ought to be able to write the equation in vertex form. Vertex form is a parentheses x minus h squared plus k. The a in standard form is the same a over here in vertex form. And that is a minus from the formula and a minus a 1. And so minus a minus makes a plus. And this stays minus. if I graphed this, would it open up or down? Why does it open up? Because that is positive. What is the axis of symmetry? The axis of symmetry is going to go through the vertex point, and so that's equal to the x value of the vertex point. What is the y-intercept? To find the y-intercept, you substitute an x, a 0 for x. That's easier to do in the standard form. You can use either form, but the standard form's easiest. Don't we want to do easiest? So here I'm going to substitute a 0, and here I'm going to substitute a 0. And this zeroes out and this zeroes out. And so what is the y-intercept? And we write it in point form. To find the x-intercept, you would have to factor, and this one looked a little tough to factor, so we're going to do that on the next problem. But we are going to, we're not going to make a table and make a real accurate graph like we did yesterday. We are going to make a very rough draft graph, and so my graph opens up, and it has a vertex point at -1, -25/2. And it has an axis of symmetry at x equals -1. This point right down here, what's it called? This is the vertex point. Is this vertex a maximum or a minimum? And the minimum value is -25/2. Often when we look at a graph, we determine the domain and the range. What is the domain? All real numbers. You can write out the word or use the symbol. The range is not all real numbers. The range has a bottom point. The arrows are telling me that the range is getting bigger. Y is greater than or equal to the y value of the vertex point. This is the minimum value, and then y gets bigger from that. There's one other thing that we need to look at on our graph. Where is our graph increasing? Where is our graph decreasing? So, if I start here on the left, you should always go left to right on your graph, and I draw my graph, what's my pencil doing? Down would be decreasing. It decreases from here all the way to here. And we put our increasing and decreasing in terms of the x values. So what is the x value right there? So it starts decreasing way over here, and it decreases until I get to this point. Well, what's that point? Well, it's not actually a point. It's an arrow. And where is this arrow going? It's going up, but it's also going to the left. What do you call it if you keep going to the left, as far as you can to the left? So if you're going out this way, this side of the graph is negative infinity, and this side is positive infinity in terms of x. So we start out here at negative infinity and decrease all the way to 1. And then what happens at 1? We start going up. So starting at negative 1, we go up and up and up, and we also go to the right and continue going to the right as far as we can. So this is telling me on the positive infinity side we're increasing, on the negative infinity side we're decreasing. Took me 2 whole pages to do one example. Example 2. Y equals negative 2x squared minus 4x plus 30. What is the A and the B and the C? What form is it in? It's in standard form, and we're going to change it to vertex form. To find the vertex, we need to memorize this little formula. So x equals minus a minus 4 divided by 2 times negative 2. Minus a minus makes a plus 4 on top and a negative 4 on bottom. That's only half of my vertex. To find my other half of my vertex, I have to do a substitution. Negative 2x squared minus 4x plus 30. And in place of the x, I'm going to substitute the negative 1 that I found right here. Negative 1 squared is positive 1 times negative 2. Negative times negative makes a positive 4 plus 30 equals 32. The vertex is negative 1, 32. So the vertex form is ax minus h squared plus k. What was my a? X minus a minus 1 makes a plus 1. What form is this called? Does it open up or down? This is negative, so it's going to go down. It's going to point down. I'm going to go have a parabola that's going to be pointing down. So is this point right here a maximum or a minimum? So it's going to be a maximum, and the maximum value, how high does it go? This is going to be all the way up to 32. We would need a big piece of graph paper if we were graphing it out on graph paper. What is the domain? You shouldn't miss the domain. It's the same on all of them. But this time the range is going down. Y is less than or equal to this maximum value. And where is it increasing? Where is it decreasing? Well, if I start over here and draw it, what's my pencil doing? It's going up. That would be increasing. It starts on the left at negative infinity and it goes up till we get to this point. This point is negative 132. What is the x value of this point? The increasing and decreasing are written down in terms of the x values. And starting at that point right there, now what's my graph doing? What's my pencil doing? It's going down. That's decreasing. So it's decreasing from negative 1, and it's going to keep decreasing forever. And if we needed a more accurate graph, that's where we would have to put points, make a table, and substitute in points. Another point that is often of use when we are graphing is the y-intercept. How do you find a y-intercept? It is easiest to find the y-intercept from the standard form that we started with. It can be found from the vertex form. It's just not as easy. Negative 2, and that's squared, minus 4, 0. And this zeroes out, and that's zeroed out. And so, in point form, the y-intercept is the c, because those will always zero out when you are solving for the y-intercept. But how do you find the x-intercepts? So in my standard form, I need the y to equal 0. Does that look like the problems we were solving last week? I need to solve for x. I have 3 ways to solve for x. I can solve for x by factoring, by completing the square, or by using the quadratic formula. The easiest way to solve for x is to factor if it will factor. If I am factoring it, the first thing I need to do is factor out the GCF. Does it have a GCF? What's the GCF? So I'm going to divide everything by -2, so my factoring will be easier. I made a mistake. Can you find my mistake? Negative divided by a negative makes a positive. Okay. Now you multiply your first number times your last number, and you write down the factors of 15. If I put the signs in the correct way, is there a way that any one of these pairs could equal to a +2? If I put the signs like that, would this equal a +2? If I multiply it, does it equal a -15? Because this is 1, I can use my shortcut factoring. You haven't forgotten factoring already, have you? I'll come back to that. It depends on what you're doing. So I am solving this, and so x minus 3, and so using my 0 property rule, either that has to be equal to 0 and that has to be equal to 0. Add 3 to both sides. Subtract 5 from both sides. And my x-intercepts are solutions and zeros and roots are all the same thing. X-intercept are the same numbers, but they're written in point form. There is one more form. We'll be talking about it some more, but we'll go ahead and do that here. Another form is root form, which can also be called factored form. Y equals a, x minus root 1, x minus root 2. The a is the same a that we used in the standard form. It's the same a that we used in the vertex form. In this example number 2, the a was -2. And we just wrote down that one of our roots was -5. And one of our roots was 3. There's a negative in the formula, and there's a negative in the formula, and there's a negative on the 5, and so minus a minus becomes a, because x is still a liar. If the roots are -5 and +3, then the root form has the same numbers with opposite signs. Now, what's the difference between root form and this that we wrote down right here? This is the factored form. These are the factors. Does it have the -2? This is the root form. Does it have the -2? But it's the same thing, but this one has the -2. As far as graphing, the -2, what does the negative do? Up or down? The negative makes it go down, and the 2, we're going to learn as we do some more graphing, the 2 makes it skinnier than the parent parabola. If we're just interested in the x-intercepts, we can divide out the 2. If we're interested in graphing the whole thing, then we need the -2. And we're going to cover the root form some more next week. Aren't you glad?